So let's go ahead and evaluate some limits here algebraically. Okay, so I would encourage you to, is kind of I'm not going to do it here on the video, but even graphing this on your calculator as we do it is really, can be insightful, right? Because hopefully when you do this, we know that first we're going to try direct substitution. Now when we try that, when we try to direct substitution, we're going to see that we get 4 squared minus 4 times 4, and then 4 squared minus 3 times 4 minus 4. We see that we get 0 over 0, which is, that's our indeterminate form. When you get 0 over 0, that means you got to try something else. Kind of not good, but again, if you get 0 over 0, you can try to factor, look for a common denominator, rationalize, expand. We'll look at those techniques. If you get like 5 divided by 0, just say the limit does not exist. Right? If you get a number like 10, then 10 is the limit. Right? So that's our first step. But we got indeterminate. So of these techniques, I think that this one, I can see right away that this numerator and denominator both factor, correct? So our second step, we're going to write limit every step until we substitute, right? Just because a lot of this, what we're doing is kind of, are you showing the work? Are you going through the process? It's not, because really we don't care what the answer is, right? But we just, the process is what we're interested in. So here, if we factor the numerator, we get x minus 4. On bottom, we get x minus 4, x plus 1. So we factored it. Those cancel, correct? So our next line can be the limit as x approaches 4 of x over x plus 1. Now once you've modified the function, whether you factor or use a common denominator, whenever you do something to it, once you've tried that, then go back and do direct substitution again. Okay, so what we're saying is that this limit's equivalent to this limit. So with that, when we go ahead and plug that in for direct substitution, we get 4 over 4 plus 1, which is 4 fifths. So that would be the limit. Okay, now, again, I would recommend you graph this on your calculator. Remember to put parentheses around the top and the bottom. When you go there and you type in 4 fifths, it's not going to give you a y, I'm sorry, when you type in 4, it's not going to give you a y value, okay, when you trace and hit 4. But if you trace and hit 3.999 and you do 4.001, they're going to sandwich 4 fifths, right? It's going to be like 0.799 and 8.0001. So it'll be right there, but I can't, that graphical connection is useful. Now our quiz, you don't have graphic calculators. You got to be able to do them algebraically, but it's a nice connection there. Okay, so we have for our second example here, we have the limit as t goes to 0 of 1 over t minus 1 over t squared plus t. Now we're still going to try direct substitution, and this is what gave me a little bit of a pause here. When you do it, and we haven't talked a lot about this, but you're not quite going to get an indeterminate form, but you're not quite going to get undefined either. It's just kind of a strange one. We're going to get, when you try it, you'll get 1 over 0 minus 1 over 0, which actually could be an indeterminate form. It's not, it's just a weird form. So we're going to still try to simplify it and see what happens. If we're able to simplify it and we still get 1 divided by 0, then we know the limit does not exist. But here we really don't have enough information, so let's go ahead and assume that it's indeterminate and kind of see what happens. Okay, so if we just got a single 1 divided by 0, we'd say the limit does not exist. Now in this case, we have a fraction minus a fraction. So looking at techniques I could try, we might try to get a common denominator, right? Get it to be a single fraction. So to do that, we'll get t approaches 0 of 1 over t minus 1 over t times t plus 1, because it is factored there. Now once we've done that, we will go ahead then and get a common denominator, which will be t times t plus 1. So 1 t plus 1 over t plus 1, minus 1 over t plus 1. It's a kind of a mouthful, right? So we have this. Let's go ahead and write a single fraction. So limit as t approaches 0 of t plus 1 minus 1 over t times t plus 1. Again, I just distributed the 1 and then subtracted 1. But if you look here, we get 1 minus 1, which is 0. And we have a t on top, and we have a factor of t on bottom. So give a couple steps here to show that. So again, limit t goes to 0. You get t over t plus 1. And notice by t's, I put little feet on them, so they don't look like pluses, which can definitely be a thing. So then from here, we cancel that, so we get the limit as t approaches 0 of 1 over t plus 1. Right, so it's simplified down quite a bit. At this point, we'll try direct substitution. If you put 0 in there, we get 1 over 0 plus 1. Now, once I try direct substitution, that's when I stop writing the limit. And it just is kind of a form there. And that's 1 divided by 1, which would just be 1, would be the limit there. So again, in this case, we didn't get the nice 0 divided by 0 form, but we got something we weren't quite sure what to do with. If that's the case, go ahead and work through the process and kind of see what happens. Try to do whatever combinations that you can. So for our next example, we have the limit as x approaches 7 of the square root of x plus 2 minus 3 all over x minus 7. Now just in terms of direct substitution, right away I can see I'm going to get a 0 on bottom, correct? Then up top you get the square root of 9 minus 3, which is also 0. Right, so this gives us 0 over 0, it's indeterminate. So we have to try some additional technique, and that is going to be, this was a weird thing that we did earlier, and you would have been right to think, I don't know why we're doing that, it just seems strange, but here if we rationalize the numerator, a lot of times this will work out, so there we have to use the conjugate. The numerator is the form a minus b, so we're going to multiply a plus b. To show that here, so we'll get the limit as x approaches 7, and then we have radical x plus 2 minus 3 over x minus 7 times radical x plus 2 plus 3 over radical x plus 2 plus 3. Right, so that's the conjugate, right? This numerator was the form a minus b, right? A is the whole square root, and then this is going to be a plus b. Okay. So with this, we'll go ahead and multiply the numerators out. I'm just going to leave the bottom factor. We don't need to. What should happen, what is going to happen is this is going to cancel out with what's left on top, and it's going to work out for us. So let's take a look and see what happens. But when you're doing this type, the only time I would only expand the denominator if I had a really good reason. Right? I wouldn't do it just because I see a parenthesis next to a parenthesis. That's not what we want to do. So when we do this, this is a difference of two squares, right? A plus b times a minus b. If you square the square root of x plus 2, you just get x plus 2, and minus the square root of 3 would be 9 over x minus 7 radical x plus 2 plus 3. And from here, if we look, x plus 2 minus 9 is x minus 7. So those will cancel. And that's the limit as x approaches 7 of 1 over radical x plus 2 plus 3. Right, so I simplified it using one of our techniques. Now once we've done that, if we go ahead and do direct substitution, and that's the square root of 7 plus 2 plus 3, which gives us that this limit is equal to 1/6. And again, you could graph that. If you got really close there, you went a little bit to the left of 7, a little bit to the right of 7. You should be sandwiching 1/6 as we look at those values there.